Today video I am going to show you that Lewis structure, geometry and bond angle of a compound. So first, to determine that Lewis structure, you need to count that steric number. So you can also see that whole whiteboard I draw a lot of structure. So this is just a common concept. So before going to that Lewis structure, you need to know that steric number. Then we will go that geometry and the effect of that lone pair. So first, to determine that steric number, you need to know that single bond is count as 1 and double bond also is count as 1, triple also count as 1 and lone pair also count as 1. So to determine that steric number, I can give you an example, right? So we already know that structure of water molecule, right? So in that water molecule there is 2 single bond, right? So 1, 2 and 2 lone pair, 1, 3, this is 4. So 1, 2, 3, 4. So this number are count as steric number. So any kind of compounds like ammonia, you can see that structure. So ammonia has 3 single bond, right? Single bond which will count as 3 and 1 lone pair which will count as 1. So ammonia also have like 4 steric number. Okay, so when we count that 4 or any steric number, then we can go through that general topics and we can go through that Lewis structure, geometry and bond angle of any compound. Okay, in this video I am going to show you the specifically Lewis structure of that PCl5 Lewis structure. Then I will show you the geometry and bond angle, and I can show you that bond angle is dependent on their lone pair or lone pair has that impact on that bond angle. So before go to that Lewis structure, we need to find out their valence electron of PCl5. Then we can go to that Lewis structure. So valence electron of phosphorus is 5, chlorine has 7 valence electron and multiply by 5 because there is 5 chlorine, you can see, so which makes it 40. Then we need to go to that Lewis structure. So before go to that Lewis structure, we need to know which one has least electronegativity, because least electronegativity element will go to that middle of that Lewis structure. This is the rule. So we know that phosphorus has 2.19 electronegativity and chlorine has 3.16 electronegativity. So then you can see that phosphorus has least electronegativity and it will go to that middle. Then phosphorus has 5, we need to set that 5 valence electron here. This is 5. Then we will set that chlorine and chlorine. Oh, I will erase that one, that part. And then I need another chlorine here. Then I will set that their valence electron, which is 7. You can see chlorine has 7 valence electron. Then I will make their bond with that phosphorus, and this one also has 7. So now I'll make the bond between them. So it will make that bond here, that here, that here, and that here, and also it will make that bond here. So if I redraw that, so this structure will be chlorine, 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 chlorine and chlorine. So then we need to figure out the steric number. So there is 5 single bond, that's mean 5 steric number, and there is no, you can see there is no lone pair electron, that's mean only 5 is their steric number, right? Then we need to match that number with that table I already drawn for you. So this number is here, you can see steric number is 5 here, and there is no electron pair, lone pair. So you can see that 0 lone pair, which means trigonal bipyramidal. So we will get trigonal bipyramidal geometry of that compound. Then we can see their bond angle, which is 120. So you can see that this structure has no impact on the lone pair electron bond angle, right? So lone pair electron does not do anything because there is no lone pair electron. So you can see that Lewis structure, which is that, then geometry trigonal bipyramidal, and you can see that bond angle, which is 120. So you will get that 3 things here, and also at the bonus point you don't have any impact of lone pair on that bond angle. You got that. But if it has, like, suppose it has one bond angle, one lone pair, so it will go like that: seahorse for one lone pair, 2 for T-shape, and others. So you see that there is no lone pair. I think you got that.